Have you ever wondered how a zipper on your jacket works? It interlocks individual teeth from two separate sides to form a single, unified closure. Each tooth from one side meets its partner from the other, joining together as you pull the zipper up. Now, imagine each side of the zipper is a list of items. Perhaps one side holds the names of fruits, and the other side holds their colors. As you zip them up, you combine apple with red, banana with yellow, and so on, creating pairs that make sense together. This everyday action is a perfect metaphor for the zip method in LINQ when coding with VB.NET. In the digital world of programming, zipping is just as handy as it is in our daily dressing routine. But instead of clothing, we are bringing together elements from two sequences, side by side, to work with them as a pair. So, let's take this simple action of zipping and see how we can apply it to our code to make powerful and efficient applications. In this video, we will explore how the zip method in LINQ allows us to elegantly merge two lists, arrays, or any enumerable collections, just like the teeth of a zipper, to create a new sequence of combined elements. So, understanding the zip method will add a valuable tool to your coding skill set. Let's dive in. After our real-world analogy, let's delve into the technicalities of the zip method in LINQ. In VB.NET, zip comes with 3 overloads, each allowing us to combine sequences in different ways, much like the teeth of a zipper come together to form a single unit. The first overload is the simplest form of zip. It takes two sequences and merges them into an 𝗖𝗵𝗽𝗀𝗀𝗀 tuple, each containing a pair of corresponding elements from the two sequences. An example of this could be zipping a list of fruits with a list of their colors, resulting in a collection of fruit color pairs. In this case, both sequences are lists of strings. So, zip will produce an output of type 𝗖𝗵𝗽𝗀𝗀𝗀 tuple of string. Each tuple will contain a fruit name and its corresponding color. Moving on, the second overload of zip works with 3 sequences. Similar to the first, it produces an 𝗖𝗵𝗽𝗀𝗀𝗀 tuple, but this time, each tuple contains 3 elements, one from each of the sequences. This could be useful when you want to combine related data from 3 different lists, like fruits, colors, and shapes, into a single collection. The output here will be an 𝗖𝗵𝗽𝗀𝗀𝗀 tuple of T1, T2, T3, where each one represents the type of a sequence. The third overload is where things get even more interesting. It allows us to specify a lambda expression, a function that defines how each pair of elements from the two sequences should be combined. This is not just about merging, it's about transforming the pairs into something new. The output is an 𝗖𝗵𝗪able of the type specified by the lambda expression's return value. Now, let's explore each one of these overloads with examples to see them in action, and understand how they can be used to make our code more powerful and efficient. Suppose we have an array of integers called numbers, and another array of strings called letters. Using the first overload of zip method in this way, we get the following collection. It's an 𝗖𝗵𝗪𝗀𝗀𝗀 tuple, of integer string. As you can see, we have 3 pairs because each array consists of 3 elements. Each pair has the first element from the first array, and the second one from the second array. To convert this collection to array of integer string, we can use toArray method. The result will be the following array, where each element is a pair consisting of 2 elements. Each pair is also written inside braces. If you print out the content of this array, you will get the following values. So, each element in the array is a pair consisting of an integer and a string. Suppose the first array contains a new number. Now, we have more elements in the first array than the second one. The result in this case will be exact the same old one. This means, the last element will be ignored because there is no corresponding element found in the second array. The same will be also if the second array has more items than the first one. In summary, no exception will be thrown in case a sequence contains more elements than the other one, but we only get the elements that have a matching element in the other sequence. Let's check another example about using the same overload with dictionaries. A sales department has 2 dictionaries. One mapping product IDs to product names, and another mapping the same product IDs to the quantity sold. The goal is to create a unified report that lists product names with the corresponding quantity sold, without explicitly iterating over the dictionary entries. Since dictionaries implement 𝗖𝗵𝗪𝗀𝗀𝗀 for their keys and values, we can enumerate over the values of both dictionaries by ordering them according to their keys. We will assume that both dictionaries have the same keys and are in the same order. The query will be as following. The first sequence represents the values of the first dictionary. The second sequence represents the values of the second dictionary. The output will be an 𝗖𝗵𝗪𝗀 tuple of string integer. The first element of type string represents the product name, and the second element of type integer represents the quantity sold. This enumerable can then be iterated over to create a report, displayed in a user interface, or used to perform further analysis. This is how to use the first overload of zip method. Let's explore the second overload of the zip method through a practical example. Consider an inventory system with 3 separate lists, product IDs, names, and stock quantities. Our task is to combine these lists to create a comprehensive inventory report. Now, here's how we can achieve this. The result will be the following collection, of type 𝗖𝗵𝗪𝗀 tuple of integer string integer. So, we get a sequence of triplets, where each triplet is formed by taking one element from each of the 3 lists. The first element represents the product ID, the second represents the product name, and the third one represents the quantity. By using the toList method, we can convert this 𝗖𝗵𝗪𝗀 into a list with the same tuple structure. Keep in mind that this overload behaves just like the first. It pairs elements up to the length of the shortest sequence. So, if our first list contains 3 items, the second list has 4, and the third list has 5, we will end up with only 3 complete triplets. The extra elements in the longer lists are simply not included in the final zip sequence. This means that every sequence must have a corresponding element in each of the other sequences, otherwise, those unpaired elements are left out. This ensures that our inventory report is accurate and aligned, with each product ID matched correctly to its name and quantity. Let's take another example about using this overload with a data table. This time, let's implement the use case in UiPath. We have the following simple sequence. First, we define a data table called customers table. This table consists of 3 columns, first name, last name, and email. We have 4 different rows. Our goal is to combine the data from these 3 columns. The result of the query will be stored in this variable. It's now of type string, but we have to define the correct data type. We will do that later. Let's first check the query. The second overload of zip method is used here. So, we have 3 different sequences. Each sequence is the content of one column. To get the content of each column, we are using select method. Each one returns an array of strings that contains the data from the whole column. This means, the first select method returns the following array. And these are also the other 2 arrays from the other 2 select methods. In other words, we now have these 3 arrays that we want to combine. The result up to this point is of type 𝗖𝗵𝗪𝗀 tuple of string. At the end we are using toArray method to get the result as an array. So, the result will be of type array of string. After the query there is write line activity to print out the result. Each element from the query will be written in a new line. Let's now define the data type for this variable. First we have to use an array. Now we have to browse for value tuple. We can do that as following. We need the third one, which contains 3 different elements, because we are using the second overload with 3 sequences. Now we have to select the type of each element. We have 3 columns of type string, therefore the type of each element must be also string. Now we have the correct data type for the variable. The sequence is ready to execute. So, let's execute it and check the outcome. As you can see, I got 4 pairs as result, each one consists of 3 elements. Each pair is written inside braces. The first one from the column first name, the second from last name and the third one from email column. This is also how to use the second overload of zip method. Finally, let's dive into the third overload of the zip method. This variant is particularly powerful, because it gives us the flexibility to define exactly how we want to combine elements from 2 sequences. The syntax looks like this. Sequence 1 and sequence 2 are our sequences, and the lambda expression after function is where the magic happens, blending each pair of elements in a custom way. Imagine we have a list of employees and a list of their respective salaries. Our goal is to combine them into a single string like this one. Here's how we could use the third overload to accomplish that. The result will be the following collection. It's an 𝗖𝗵𝗪𝗀 of string, because the type we used in the lambda expression is string. We can convert this collection to array or to list of strings using toArray or toList methods. Now, let's see this in action with another type of data. Consider we have a sequence of products, and a corresponding sequence of Boolean flags indicating whether each product is in stock. We want to create a list of informative strings that denote the stock status. If the product is in stock, we want to get in stock, else out of stock. Here's the query to do that. The result will be the following 𝗖𝗵𝗪𝗀𝗀 of string. The beauty of this overload is in its flexibility. We can define any result type we want in the lambda expression, whether it's a string, a custom object, or any other type that suits our needs. This overload is especially useful when we need to perform some calculation, or apply a transformation to the combined elements, rather than just pairing them up. It's an invaluable tool for tasks such as data reporting, complex mapping, or creating richly formatted output. And there you have it, a comprehensive look at the zip method in LINQ. We have explored its real-world analogy, understood its three versatile overloads, and seen it in action through various examples. To summarize, zip allows us to efficiently merge two or more sequences into one. The first and second overloads help us pair up elements from these sequences, creating tuples that encapsulate related data. The third overload goes a step further, giving us the freedom to define complex transformations for our combined elements. Remember, the zip method is not just about pairing. It's about creating meaningful connections between data. It shines in scenarios where data from different sources need to be correlated, such as in data reporting, creating composite keys, or when preparing data for batch operations. As you move forward in your coding journey, consider the zip method as a valuable ally. Whether you are handling arrays, lists, dictionaries, or even data from data tables, zip provides a neat and elegant way to bring together disparate pieces of information. So I encourage you to try it out in your next project. Think of zip whenever you need to interlock data, just like the teeth of a zipper on a jacket. The applications are vast, and with a bit of practice, you will find zip to be an indispensable tool in your development toolkit.